So in a previous video, we learned about what the vertex of a quadratic is, and it's this important point where this turn happens. And in this video, we're going to look about how do we find that if we don't have the graph at the start. So again, the vertex is where that turn happens. If we have our quadratics, and they can be a bunch of different shapes, as long as they're all that general U shape, then the vertex is where that turn happens in the quadratic. All right, so it's really important, especially when we go to graph these by hand. It's really important to identify the vertex because it's a nice point that gives us where the shape of our quadratic is going to be. All right, so the first thing we're going to do is figure out some relationship between the equation of our quadratic and the vertex. All right, so in this example, we have the function given to us, and it's already been graphed for us, and we're going to find some relation between the vertex and the expression for the function. All right, the first thing, let's identify the vertex of this quadratic. So the vertex is going to be down here where the turn happens, and that is the point 3, -2. So if we compare the point 3, -2 to that equation that we started with, what do you notice? Well, there's a 3 here, and there's a 3 there. There's a -2 there, and there's a -2 there. All right, so it's going to turn out that this form for a quadratic will basically just tell us where the vertex is. So in this exact form, it gives us a lot of nice information. We know where the vertex, where this turn is going to happen. And because of this is called the vertex form for a quadratic. All right, so vertex form is another way we can write a quadratic. I don't think I actually put it in a slide, but I would say the standard form is the one that we use when we're doing the quadratic formula. The standard form is ax squared plus bx plus c. All right, so when we look at vertex form, we have an a. It's actually the same a. It'll be the same number from standard form. All right, but instead of a b and a c, we have this h, and we have this k. All right, this h is with the x and this parentheses and this perfect square in the middle. And whatever this number h is the x value of the vertex. And whatever this number k is the y value of the vertex. All right, there's only one thing you have to be really careful with, and that's this negative sign here. All right, so the formula has a negative sign. So if you see a negative in your formula, that actually means h is positive. If you see a positive, that means you had a negative, which turns it into a positive. So we'll see this in the example. All right, but remember that there's a negative sign in this formula that kind of tells you what the h value actually is. All right, so here's what I mean. All right, find the vertex of this quadratic. As you saw from the last slide, this a value here doesn't affect the vertex at all. We'll kind of see what that affects a little bit later on. All right, but we don't have to worry about this number at all. We're just looking at h and k. So h is the number inside with the x. K is the number at the back by itself. All right, so what is our vertex going to be? The k is always the easier one because whatever number you see here is just the answer. I get 6. All right, so 6 is the y value of my vertex. But if you go back to the previous slide, there should be a minus sign in our formula. All right, so my x value of my vertex isn't 5. It's not just the number I see. It's kind of the opposite of the number I see, -5. So I do minus -5 in the formula. Those two negatives cancel and give me +5, which is actually what I see. All right, so the basic idea is the k value, the y value, you just write exactly what you see. The h value, the x value, you write the opposite of the sign you see. And that's just because there's a minus in the formula. All right, so go ahead and try this one on your own. I find the vertex of this quadratic. And the vertex is at -2, -8. Again, for the x value, it's the opposite of the sign you see. So that positive tells me it's -2 for my x value. But for the y value, it's exactly what you see. So -8 is that. So kind of have to, one weird thing to remember is that your x value is going to be different. Your y value is the same. All right, so we saw this nice vertex form. It basically just tells me where the vertex is as long as I remember that kind of weird thing with the x value. All right, but not every quadratic is going to be in vertex form. For instance, we mentioned standard form. That looks like this. All right, but we can change things into vertex form. Vertex form has this perfect square right in the middle. And if it has a perfect square, to convert something into a perfect square, we do something we've done before, and we do completing the square. All right, so we have to recall what completing the square is, how to do it, and we'll have to make one change because we're working with a function and not an equation. All right, but again, the great thing with this class is you can kind of go back and remember what completing the square was, all right, and then we can do our examples. All right, so we're going to find the vertex of this quadratic. Again, if we want to find the vertex, we have to get it in vertex form. And to get it in vertex form, that means we have this perfect square up here, which means we need to do completing the square. All right, so the way we did completing the square before is we would have got rid of this thing by subtracting it from both sides. But we can't do that here because we have a function instead of an equation. We can't like subtract both sides from this function expression, even though there is an equal sign. That's not really how it works. You just have to make one small change. All right, but we're going to do the same thing and kind of ignore this plus 3 at the start and just worry about x squared minus 4x. All right, when we do x squared minus 4x, our b value is negative 4. And our steps for completing the square aren't going to change. The first thing we do is divide that number by 2. And that gives us negative 2. And the next thing is we square that answer. So whatever that answer was, we square it. So we do negative 2 squared, and we get 4. All right, this tells me that 4 is a thing I need to add to x squared minus 4x in order to create a perfect square. So I want to do f of x equals x squared minus 4x plus 4. All right, this part here, now that I added 4, is a perfect square, because that's what that told me. But I still have this plus 3. And here's where this is going to be different than completing a square with an equation when you're doing it with a function. I can't just add 4 to a function because it'll change what function I'm talking about. If you add 4 to a number, it becomes a different number. But here's the weird thing we can do in math. If I add 4, if I really don't want to change anything, what I can also do is subtract 4. All right, so if I add 4 and subtract 4 at the same time, nothing happens because 4 and negative 4 cancel out. Right. What we want to do is leave the plus 4 and the minus 4 in different places. Because this green part, that is the part that's going to turn into a perfect square. X squared minus 4x plus 4, we use the other part of this process, this negative 2 here. That's going to turn into x minus 2 squared. And so completing the square, divide by 2, that number goes here. And you square it, the other number goes there. And the second half of this, 3 minus 4, should have put that plus sign there because that's going to be a negative 1. All right, so in order to add 4 to get this perfect square, I also have to subtract 4, so I don't actually change what function I'm talking about. But now this function, x minus 2 squared minus 1, is the same as what I started with, and now I know my vertex, because now it's in vertex form, is positive 2, negative 1. So it is just completing the square with only one weird difference of doing this thing where you add the number, you subtract the number as well, because that doesn't change what function you're talking about. All right, we're going to do one more example, but again, it's going to be the same process. So the first thing we're going to do is ignore the constant term, the number by itself, and we're just going to look at x squared plus 10x. All right, we take our b value, which is 10, and so b equals 10. We divide it by 2. That's 5. That number will be important later, but not right now. And then we square that number. 5 squared is 25. All right, so that tells me is I need to add 25 to x squared plus 10x. All right, so that part, what I just wrote, is going to end up being my perfect square. But I still have other stuff to worry about. I still have this minus 2 I've been ignoring. And since I added 25 in my function, I also have to subtract 25. All right, so really all that's changing from this first step to the second step is once I find this number, I add it in one place and I subtract it in another place. That means I'm still talking about the same function. And again, there's going to be the first 3 terms are going to combine and the second 2 terms are going to combine. All right, the first 3 terms the whole reason we created that is because it turns into the perfect square x plus 5 squared. Again, that 5 is coming from there. And a negative 2 minus 25 is negative 27. So that's completing the square. Same steps of dividing by 2 and squaring it, but then we have to do this other thing of subtracting that number as well. And then now we can find our vertex is negative 5. That's the opposite of the 5, minus 27. All right, so this is how you find the vertex when you're not given vertex form. All right, so go ahead and try this one on your own. And here's the solution I got. So the thing I need to add to for the perfect square is 9. So I also subtract 9. And my perfect square turns into x minus 3 squared. 3 and negative 9 makes negative 6. And then again, opposite sign for the first part, so it's going to be positive 3 for my x value. Same sign for the second part, negative 6 is the y value of the vertex. This is how we use completing the square in order to find the vertex of our quadratic. All right, so the skill check is going to have 2 questions in vertex form and 2 questions that you have to change the vertex form. So the questions in vertex form should take no work. You just go directly from the equation to the answer because it's in vertex form already. The other 2 questions you have to do completing the square, just like we did in these last 3 examples. Once you do completing the square, then you do the same thing as the first 2 questions and write down your vertex. All right, so exactly the types of questions that were in this video are what are going to be on the skill check.